So before I get into talking about the review, what you guys kind of need to study for the test tomorrow, I wanted to make you aware that I pushed the due date for 6/2 to be tonight by midnight, because I know there was some issues with the page loading on last Thursday. So if you didn't get it done by last Thursday, then it's due at midnight tonight, so it's still not late. Right? So that's 6/2 and 6/3 are due by midnight tonight. So any questions about that homework? Any problems on there? I know 6/2 was kind of the tough one that I went over in class on Thursday. All right? And then 6/3 is basically converting from your population mean to your sample mean, your population standard deviation to your sample standard deviation. And then it's pretty straightforward from there, really. Right? All right, so let's look at the review right here. So paper reviews and formula sheets. Here's your exam 3 review. I did point this out in class on Thursday. This is the stuff to be ready for the exam. All right? So once again, you'll notice the stuff that's in yellow is something you will have on your formula sheet. All right? So for your uniform, you'll have your formula for your mean, your formula for your standard deviation, and then your formula for the probability. All right? Which is just basically width times height, right, is all that is. Because it's a rectangle. So that's for 5.1 and 5.2. 5.3 deals with understanding z-scores. That's something everybody needs to be able to do. Notice if I took this formula, which is z equals x minus mu over sigma, and solved for x, I would multiply both sides by sigma, so I would get z sigma plus mu, which is where that comes from. So that's the same formula. They've just solved it for x, and here it's been solved for z. All right, so make sure you understand how to use those. Remember, the unit on the z is standard deviations, right? So if z is 1.5, that means 1.5 standard deviations above the mean. Then we have 6.1, 6.2, and 6.3. 6.1 is basically just definitions. 6.2 is more definitions, but we also do this sampling distribution, right? Be able to find the sampling distribution of a sample statistic. And then 6.3, be able to describe the sampling distribution of, so here's where our sample mean is equal to our population mean, our sample standard deviation is equal to our population standard deviation, divided by the square root of the sample size, or the square root of n. Right? And then it comes up with your x bar. So what they've done is instead of putting our sample standard deviation, they put what it's equal to in its place right here. Same thing. Formulas I'll give you on the formula sheet. All right? So notice in 5.3 and 6.3, we're using a lot of this z-score stuff. Make sure you understand the z-table. That's very important. If I tell you what's the probability that z is between two values, make sure you can read the chart and tell me the area under the curve, right between the two values. So let's go look at the textbook, because I wanted to point out, the two summary pages that we've looked at after each chapter. So chapter 5 is on page 262. So my plan for today is to go over this stuff, kind of give you a summary. I'm going to show you another place where you can go get some practice problems, because I know everybody likes more practice. All right, it's not for a grade, it's just extra practice problems. And then we'll go over to the computer lab for probably the last hour and 15 minutes, and then let you guys work if you haven't finished your homework. All right, so let's go back to the textbook. So 262 is the chapter 5 summary. And here's the page with the key terms. Make sure you understand what these things mean. Remember, if there's a star, we didn't cover the starred items, so you don't need to remember correction for continuity, exponential probability distribution, that type of stuff you don't need to remember or need to know because we didn't cover it. But the words that don't have the star, you definitely need to understand And if I asked you, what does it mean for a distribution to be random? Or what is a randomness distribution? What does that mean? All right, make sure you can answer that. What is the bell curve? All right? So there's the key terms for the section. Key symbols. First is our function notation. And we don't really use E and pi. E and pi are used to construct our normal curve, which we don't really deal with. We just read the z-chart. But this theta we do have, right? Because that is, it represents a parameter of our population. Theta could be the mean. In this case, it's just the mean of the exponential, but for chapter 6, it could represent the mean, standard deviation, or the variance, right? Any of our population parameters. And then here's just some graphs, methods for assessing, normality. We didn't really talk about either of these. We've talked about stem and leaf displays in the past. We've really spent a lot of time talking about histograms, though, right? Creating a histogram from our sampling distribution. And then formulas down here at the bottom, which you will have on your formula sheet. Once again, you won't have to worry about the exponential. And you don't even need to really worry about the function here, right? But you do need to understand the z formula. So it's really just our probability, the z, the mean. Right? We really don't use this function to determine, because this says, well, if x is a given value, what's f of x? I never really ask you for that question. Right? What's the frequency of a given x? That's a pretty ugly formula that we haven't really messed with. We've seen it, right? That's the formula that creates our nice bell curve, our nice flowing shape. All right? And then on the next page, we talked about two types of random variables. In this test, we won't deal with discrete, right? Our binomial random variable came from chapter 4, which was the previous test. That's a discrete probability distribution, a success or a failure. This test is going to deal with continuous random variables. We have two types of random variables to worry about. One's uniform, and the other one's normal. We didn't cover the exponential model. So these are our two continuous random variable distributions. The uniform, which is also known as the randomness, right? Every x value between C and D is equally likely to occur. Right? Its frequency is the same across the entire interval. Here the frequency is not the same. Right? This x value right here is the most likely to occur because it has the highest or the largest f of x value. All right? And once again, the uniform stuff is pretty straightforward. Right? There's not a whole lot to it. Make sure you can answer questions like 115 and 116. All right? And I'll give you the z-chart. You won't have to memorize the z-chart. I'll give you a printout of it. You know, you'll have the necessary information. But if I tell you what's the probability that z is less than or equal to 2.1, you have to be able to answer that. All right? Those are very important. Same thing like 117. Right? If I give you a mu and a sigma, you have to be able to take it to a z, right, to standard normal, to the z formula, and tell me what does 75 refer to in terms of z. And then tell me what the probability is. What's the area under the curve for the given z value? If x is 75, mu is 70, and sigma is 10. What's the probability for E going to be? Anybody have a guess? What's the probability at 1 point? What's it going to be at 1 point? How much area is there at 1 point?
1 point from the mean?
Well, just what's the probability of x just equaling a given value? What's the area under the curve at just 1 point? 0. There's no area. or it has to be an interval. This is talking about, now in the discrete probability distribution, we could find this. But in the continuous, when x is equal to 75, it has no width, right? It has no area. That's the same reason why greater than or equal to doesn't change the probability at all, right? Because at the given point, there's no area. Stuff you have to be able to do. Right here is where you would basically have to read the inside number from the chart and find the corresponding z-value. The best way to do that stuff would be to draw a picture. All right? So let's try one. Let's do 116E. Let's see if we can answer that. And I'm going to start off just by drawing a picture of it. So, 116E says, find the probability. So I'm looking for the z-value such that the area greater than it is equal to 0.8023. So this one, I know the area, but I'm looking for the z-value. Right here, the z-value is 0, right in the middle. It's an ugly z. There we go. Now it says 0.8023. So I need to find a z-naught such that all the z that's greater than it is 0.8023. Now how much area is half the curve? 0.5, right? So here's 0.5. So I need to find a z-value, right? This is my z-naught, such that what's the area of this piece going to be? What does it have to be? If this is 0.5, and I want it to total 0.8023, well, just take away 0.5 from this. Wouldn't it be 0.3023? Right? Right. Yeah, you went the opposite direction. Because what it's saying is, I want all the z-values such that when it's greater than z-naught, the area under the curve is 0.8023. So does everybody see that z-naught is going to be a negative value here? It has to be, right? So I want all the z-values such that when I put together all their area, it equals 0.8023. So I need to go to the chart and find the z-value that corresponds to 0.3023, but I need to make sure it's negative, right, because it's to the left of 0. If this had been flipped around like this, then the z-naught would be over here, right? Z is less than or equal to z-naught. So that's the opposite side of it. So let's go look at the chart where it's 0.3023. I think it's 773. Right there. 0.3023, so 0.85, but it's negative 0.85. So the answer is the probability that z is greater than or equal to negative 0.85 is equal to 0.8023. That's the answer. Right? It's looking for the z-value that incorporates that much area under the curve. All right? Stuff like that you have to be able to do. All right? That's a typical problem that we could see on the exam. And the best way to do it is to start with a picture, all right? So that was 116E. So you'll notice this, it says P, the probability that z is greater than or equal to z-naught is equal to this little bitty area. That's going to be all the way on the right-hand tail. Right, does everybody see that? Because z-naught's the value, I want to know the area greater than z-naught is 0.0041. So that's going to be the very right-hand edge of the graph. So basically, I need to do 0.5 minus that to use my chart. Right? Because the chart doesn't give me the tail, the chart gives me the inside part. All right? So 15, 16, and 17 are definitely problems you need to be able to do. All right? Definitely. That's the type of stuff that you will definitely see on the exam. Now, you won't see these exact problems, but I mean a slight tweak and it'd be just like this. Okay? So that's chapter 5. Let's go look at chapter 6, which is on page 292. So chapter 5 is 262. Chapter 6 is 292. Key terms. Biased estimate. Remember, if the sampling statistic is not equal to the population parameter, we say that it's biased. Right? These two things have to be equal for it to be unbiased. And really, going back and looking at your homework again will help cement that idea. Right? Notice the means of our sampling distribution. So this is once we know it is unbiased, we can go ahead and use these values. All right? So key ideas, let's look at these definitions. Sampling distribution of a statistic, the theoretical probability distribution of the statistic in repeated sampling. And this picture down here shows a pretty good idea of what's going on in that definition, and we'll get to that. Right? What is an unbiased estimator? A statistic with the sampling distribution mean equal to the population parameter being estimated. All right, so the mean of the sampling distribution is equal to whichever parameter we are estimating. And it could be the sampling distribution of the standard deviation. All right, the mean of that needs to be equal to the population parameter for it to be unbiased. If it's not equal, then we say it's biased. All right. The central limit theorem, which is a pretty awesome concept. The sampling distribution of the sample mean x bar is approximately normal, regardless of what the shape of the population is. All right? The sampling distribution will always be approximately normal. All right? The sampling distribution of the sample mean. This does not say anything about the population mean, just the sample mean. All right? And here's some fancy notation. Theta symbol represents any population parameter, whether that population parameter is mu or sigma, right? So it depends on the situation. All right, let's look at this little picture right here. It's a pretty neat thing what's going on. All right, so generating the sampling distribution of x bar. First, select the sample size n. We're going to say it's large. We don't know how big large is. But a good rule of thumb is what number for it to be large? 30. And it even says it right here. 30, the number of trials, if it's greater than or equal to 30, we say that's sufficiently large. Right? So here's the population. We take, say, 30 samples out of the population, and we find the average. All right? We find the sample mean. We do that over and over and over again. So we create these sample means over and over and over based on different random samples from the same population. Then we take all of these different x bars that get created and create another sampling distribution. That sampling distribution will be normal, regardless of what the shape of the population is. This is a pretty amazing thing. Notice it says right here, unknown shape. We don't know the shape of the population. But as long as we take a sufficiently large sample, its sample mean distribution will always be normal. Right? Which is really pretty amazing. Okay? And that's basically it for this section, as far as the stuff to remember. Starting on the next page is already practice problems. Right? So this this chapter is pretty abstract in a sense. I mean, this picture right here, there's a lot going on in this picture, even though it really doesn't look like it. There's a lot going on. Now, the cornerstone to this sampling is that these N items from the population are chosen at random, right? They can't be chosen by a person, right? They have to be chosen at completely random, or randomness, right? So there's the stuff to be studying for, right? To be used to seeing on the exam. These formulas I will give you, all right? Once again. So here you just take the square root of whatever the sample size is. Okay, now I want to show you where to find some extra practice problems, which I know some of you have already asked me about this. And I haven't really showed you in the past because we haven't really needed to. But I think for this test, a little more practice will definitely be useful. All right? So everybody notice over here on the left-hand side of the page, it says study plan. Everybody see the study plan button? The study plan basically pulls questions out of the textbook. It doesn't charge you for them, though, which is to say it's not for a grade. All right? So if you get 100, that's great. That's good practice. If you don't do all of them, it doesn't count against you. So these are here simply for practice. All right? So what I want you to do, after you click study plan, click view all chapters. And notice it pulls all the chapters we're going to cover in this class. Now, we're not going to get to chapter 11. So after tomorrow, we'll take the test tomorrow, and then starting Wednesday, we'll start in chapter 7. All right? So you have 2 more chapters to cover, 7 and 8. And it looks like the test for chapter 7 and 8 is 2 weeks from tomorrow. Okay, so the 21st will be that test. Then the 22nd we'll review for the final. And the 23rd we'll take the final in here. Okay? We've only got 3 weeks left. Now, to practice, go ahead and click on chapter 5, right? That's the first section, or the first chapter from this test. And then notice it has 3 different sections. The 3 sections we covered. 5.1, there's no exercises. Right? It was basically just definitions. Then you can go ahead and click 5.2 and get in there and just look at the uniform, or you can click on the, oh, it wouldn't do that. Yeah, you got to go in there. So click 5.2. Notice it pulls questions up from 5.2. These will look just like your homework, but it's nice just to get more practice problems. Right? So you can go in there. 5.2.3. Now, there could be some of these problems that we didn't exactly cover. If it's something you don't recognize at all, just skip it. Because I haven't went through the study plan and kicked out questions we haven't covered. Right? So it is possible. Man, look at this thing. There we go. But this is definitely something you guys can do. Suppose X is a random variable, best described by a uniform probability distribution. And there's our endpoints, 25 and 55. So the range is 30, right? That's why there's this 1 over 30 here. So it's a dead giveaway. It's got to be one of these 2 formulas. It's definitely not going to be B or D. Right? And if you need help, here's your textbook, view an example, ask my instructor, or shoot me an email. Right? So a lot of practice up here. And this is just for section 5.2. Same thing. All right, so lots of practice on this. Anthrax spores. I think you guys did do that one for your homework, right? But you can go in there and try it again. And this isn't to mention the quiz that's due tomorrow as well, all right? So there's plenty of practice for you guys. So I can click OK. Maybe I get through 5.2. I feel good about it. I'm going to go click 5.3, and there's some practice problems. That is section 5.3. So start on 5.3.23 and go from there. All right? Definitely something everybody needs to be able to do is this Z-score stuff. All right? You have to be able to answer these questions for me. And notice it has the click here for a table. This will be the table I'll give you for the test. All right? This exact same table. So make sure you can interpret it. And pay attention to if it's asking for the area to the right of Z, right? To the tail. Remember to do 0.5 minus the area that it's giving you. So Oscar, I was showing him the study plan here. This is just more practice problems. So click study plan on the left-hand side, view all chapters, and then there they are. So then I can go in here to chapter 6 and go in and do problems from there. So there's a few questions from 6.1. And 6.2 was the tougher one, right? So here's a bunch of, well, not a bunch. Here's 5 questions from 6.2. All right? So rather than me sit up here and do examples, I think the best way to tackle this from now, or for today, is to go to the computer lab and you guys kind of work on it on a case-by-case basis. All right? So you work on what you're struggling with. I'll walk around the room and help you guys out. All right? So we can do the one-on-one help. Haley and I will walk around, all right, and help. Okay? So there's study plan stuff to practice. You have your quiz that's due tomorrow by 9 a.m. right here. All right? And then these 2 homework assignments are due by midnight tonight. So in order to leave early today, I want to see 6.2, 6.3, and the quiz review done. All right? You don't have to have the study plan done today to leave early. But I want to see at least those 3 assignments done. Okay? Any questions? Where's my sign-in sheet at? Got it? Okay, there we go. All right. So let's walk over to the computer lab at JWLA and get started. Get the computer started up because it takes about 10 minutes before you can log in. So. Thank you, Oscar.